Okay, last day we were discussing about Python, but actually I was just roughly explaining the question. So I said that I'll be explaining this more today. So let's do that and let's try to understand what's going on there. Right? What you have to do is like take Python and I'll just give the basic concepts only, but don't expect everything because Python is a big lesson. Like it needs closer to at least 50 hours to cover the entire lesson. Therefore, I will like question to question, I will explain this. Actually, here in this question, you can clearly see they are using control structures. So today I'm explaining control structures to you very quickly. So there are three control structures in programming. So one is called sequence. Sequence is basically where the instructions are executed one after another. The second one is selection, where the instruction flow is selected based on a condition. The third one is repetition, where the instruction flow is repeated again and again. In flowcharts also, we have learned this kind of thing. Actually, flowchart is the planning tool or designing tool. Before we do the actual programming, flowchart need to be created. Right, let's see sequence selection. Actually, I miss my notes because those are in Sri Lanka. I'm out of the country. Therefore, for the moment, I'm using notes, notes which are in the internet. Later, I'll give you my note to you. Okay, see here. So this is how we represent these three control structures. Sequence is instruction flow is just repeating one after another. Selection is you have alternatives. It's like a junction. You have to decide either to turn right or left. You can't turn both sides simultaneously. Right? Simultaneously, you cannot turn both sides. You have to turn either right or left. You have to decide that. Repetition is you are doing the same thing again and again until a certain condition. Then we call that a repetition. Actually, like selection and repetition look same because the same symbols are used. But there is a one way to identify that. Here in this, see the arrowheads moving down and never come back. Here also arrowheads moving down, it's never come. But here you can see the arrowheads moving down, but it is coming back to the same place. That is what the repetition. So if arrowheads are arrowheads are coming back, that is repetition. If arrowheads are not coming back, just moving toward one direction, we call that is selection. That is how we can identify these two easily. Okay. Let's move to the other part. Okay, this is one more example. You can see start to stop actions are repeating selection, the decision. Here you can see it's coming back, that is repetition, right? We can see examples too. Is there any good examples here? Okay. Let's do a few examples very quickly. Here this is an example for repetition. You can see the arrows are coming back. Actually, we start from x0, then the decision is x when x is less than to 10. So x0 is anyway less than 10, then it's just do the task, come back, increment x, add in 1 to x. Now x is 1, 1 less than 10, do the task. Now x is 2, increment by 1 means x is 2 now. Again, go there, x is less than. So likewise, x will be incremented. Finally, so this will be incremented 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. 10 less than 10, yes. 10 less than, 10 is not less than 10. It's going up to 9. 10 is not less than 10, it's equal. So therefore, it will go to the no side and terminate. Okay. I hope you at least you got some idea about this. Now let's practice this using Python IDLE. So after the planning, then the implementation part is there. Implementation can be done using a programming language like Python. Okay, let me write first set of instructions. Let's say you want to add two numbers. You can say N1 equal input, enter number 1, N2 equal input, enter number 2. This is an example for sequence. You are just adding the total equal N1 plus N2 and printing the total. You can just display with a message. Total is the total, and then this is the end of the program. We can just, this is actually sequence dot py. You can save, no need to save in the same name, but just to remember that, let me run this, and when you run this, it asks the first number, second number, then the numbers will be added and displayed. But you can see when they add in the numbers added this way. Actually, why is that? Because these numbers are integers. When these numbers are strings. When the numbers are in strings, it will be added this way. Right? You can just copy down if you want. And if you draw a flow chart with the proper symbols, you know the flow chart symbols. The first starting with this ellipse or rounded rectangle. Inputs use parallelogram. You can say input number 1 is a parallelogram. Input number 2 is another one that is also parallelogram. Input output both displayed using parallelograms. Then what? The add-in. Add-in is a process. Process are displayed using square process. Then the output. Output is also a parallelogram, printing the total and then stop. This is how the flow chart is created. Just using this drawing symbols, I'm showing this. Then, since this is sequence, the arrows are flowing downwards. Or you can see it's only one direction. Arrows are flowing one direction. So you can write inside these boxes. The first box is start. This is how the flow chart is created. The first box is start. The second box is, you can say, enter N1 or input N1. Enter N2 or input N2. Here you can say tot equal N1 plus N2. Here display the total and stop or the end. This is how you write the flow chart. You draw the flow chart, sorry. This is example for sequence. So this example is shown here. So what's the mistake here? How can I correct this? Why these numbers are added as strings? So how can I correct this? I have to type the data type, right? Because this will consider this as a string. String can text delete that. These numbers will be added as a chain of text. Then if you want to convert this to a number, you can put int or float. If it is a decimal number, you can put float. Otherwise, int to convert the number. So when you convert the number like this, when you run this, run module, okay, you can see it's added as mathematical addition. Now this has all the examples, flowchart, the related code, as well as the results. Earlier it was given just string addition, which is called concatenation. This kind of addition is called concatenation. That is like a chain. It's like a chain. 34, then 23. This addition is called concatenation. It uses plus, but strings will be concatenated. For an example, here you can add hello to hi. That is concatenated. You can add 5 to 6. It is concatenated 56. But if you mention 5 and 6 without quotation, it is mathematical addition. Strings will be added this way. Maths numbers will be added this way and giving the total difference. So earlier when INT part was not there, so what has happened? When INT part was not there, it's just studied in 1 and in 2 as strings. So this is the first control structure, sequence. The second control structure, if you need time, you can, so don't write down this. You can just take a screenshot later. You can write down this in your book, right? Otherwise, it will take a long time to finish. Okay, number 2 is selection. The second method is second kind of control structure in programming is selection. So what is sequence? I couldn't write that. Sequence is instructions will be executed one after another. That is called sequence. Instructions will be executed one after another in a flow sequence. Let's play everything. Let's say you are given another example to find the maximum from given two numbers. You are asked to find maximum from given two numbers. Right? Then it is selection. What is selection? Instruction flow is selected based on a condition. So that is called selection. So for an example, you are given a task to find the maximum from two numbers or three numbers or four numbers or 10 numbers even. Then you have to select one path. Start. Enter the number, first number and the second number. Similar to the previous one, you can just input the first number, second number. I'm just using one box. This is also acceptable. You can input both using one box, one parallelogram, acceptable. Nothing wrong there. Then we have to compare. Compare means you have to take a decision. Based on decision, you have to either print the first number or the second number that need to be decided. One side is yes, the other side is no side. So the instruction flow is selected based on a condition. Then you have to merge the instruction flow and end the game. Merging can be done using circle to stop, ellipse again. This is very simple example for selection. Very simple one. First you are checking. First you are checking, enter in number 1 and number 2, x and y. These are two numbers. After entering, you are checking whether x greater than y. If x is greater than, if it is yes, print in x. That is the large number. If it is no, the other one is the large number. You are printing that. Finally, you merge both flows. You can see it's not going up. It's only coming two directions, but not going up. Either you have to select this part or this part. Only one of these part. That is what the selection is, right or left. Then stop. So let's alter the code according to that. You have two numbers, input two numbers. This is correct. Then here you have to use if condition. If condition, you can say if I'll replace this with x and y. If x greater than y, colon mark, then there will be automatic space. This is very important. This automatic space that I'm highlighting is must, is compulsory. Don't erase that. When you press enter, automatically it will put an space. That space is compulsory. That indicate this belongs to the code segment that I'm going to write here, belongs to this if. So this space is compulsory. Don't put manual spaces. It should be the automatic spaces, space generated from the IDE. You can say print x is the largest. Else, now you have to remove the space. If not, print y is the largest. So that is the end of the program. Let's run the program now. It will take two numbers. You can say it's printing the largest one. No matter which order you are entering, I have entered the large number certain. Now let me input the other way. You can see still the 65 is largest will be displayed there. Okay, that is called selection. Okay, I'll give you a small question. Can you send me code to find the large number from three given integers? Can you send me the code? Can you send me the code to find out the large number from three integers? This is only two now. When three integers are given, what is the large? Send me the code for that. I'll give you 5 minutes. This is evaluating two numbers. I need you to evaluate three numbers. Number x, y, and z, three numbers. Then find the largest from that. Do it quickly and send me the answer. Python. But anyway, this is like it's easy. It's easy. It doesn't sound that much difficult. Only thing is like you have to compare a little. You have to take three inputs and oh, this is analysis. Don't lose that. This is not an algorithm. You can use this max, but that is not an algorithm, right? So that is not an algorithm, right? So if you write this answer, maybe you will not get, even though the answer is correct, you will get the answer. But the thing is, in the examiner, so because they are testing your algorithmic knowledge, not about the tricks. Yes, it is possible to find this using the function, but the function is already there. So unless they ask you to use the function, or unless they are given, like they allow the function, don't use it directly, right? It's okay, yes, you can use, but the thing is that is not the way. So let's say XYZ is another number. Send me in the WhatsApp. So which WhatsApp? Oh, this one? Yeah. Okay. That's correct. Correct. Right. You can do it several ways. Several methods are there. Anyway, so whatever method that you have applied is also correct. Let's go to Python. X, Y, Z, three numbers are input. Then you have to check like X. So let's do like this. So if you check X, Y, Z. Okay, you can check both, right? X equal X greater than Y and X greater than Z. then surely x is the larger now. So both conditions, if x is greater than y and x is greater than z, then surely x is the largest. No doubt about that. If not, else you have to compare the other two. Because x is now out of the box. If x is not the largest, if x is greater than y and x is greater than z, then x is the largest. That is for sure. If that is not the case, that means else, you can check if normal way, if y greater than z, if yes, then this automatic indentation should come, so that you can just put enter, and when you put enter, that line will come. Then you can just erase it few times, that will go there. So then if y greater than z, then okay, else can say z is the largest. Module. Okay. Number 1, 2, 3. 45 is the largest. Good. Checking it again. There are several ways, right? Several ways of doing this. Let's input the other way, the number order. Number order, always consider, like when testing, these are testing, right? These are testing mechanisms, because when you're testing, you have to test with different value. Don't just test for one value. I'm swapping the numbers and giving this time. This like 34, I'm giving it first, then 45 in the middle, and 23 at the last. Still, you can see 45 is discovered. Okay, I'm trying one more time. I have to put this to as the last item. Then I'm putting 34 here, 23 here, 45 here. Still it's getting, right? So still my tests are not over. I have to test one more time. I have to swap this to 23, 34, and 45. Still, you can say 45. So it seems okay, right? With all these combinations working. I can try one more. That's by giving like 45 first, then the 23, and then the 34. Still, it discovers. Doesn't matter. So our code is correct. This is one of the simplest way of testing this. Oh, so there are some other ways. Of doing. So let's copy this down and paste this one more time. So this is another method of doing. Copy, paste. So as our student suggested, who the Situm suggested, you can first check two numbers, then next two numbers, N1, N2. But you have to check with the other number also, Situm, right? Otherwise, like, I think you are in trouble. This you have to test, because you cannot directly decide. What about entry then? You are not considering entry, right? You have to consider entry. Otherwise, like say N1 is 50, N2 is 40, and entry is 70. Then this will take a blind decision. The N1 50, N2 49. 50 is the largest scale, make 70 check. You have to check that also. Right? So therefore, be careful with that. And when you are writing the code, the logic should be correct. So there are several ways of doing that. You can first check is at an X line likewise, or you can check if this and if this and if this. That is another way. Right? You are checking the first one, then you are checking another condition. If, then another condition. Then you are checking whether y greater than x and y greater than z. You are checking the same condition with y. Then what? So this is another way of testing. Then you can say y is the largest. Then if both are failing, then surely z is the largest, right? No need to even check. Or you can check colorful. If you can check z greater than x and z greater than y. Then z is the largest. You are comparing the number with other two numbers. So this is also another way of doing the same. Now you will get two answers. When you enter the numbers, here you are getting 2 answers, but still that is another algorithm. You are checking 2 by 2, comparing that with the other 2, remaining 2. Okay, now you know selection. The third is repetition. The third is repetition or repeating. You are checking. Basically, you are checking repeating instruction. You are printing or doing something repetitively. That is the third control structure, repetition. So please write down or copy this down. Repetition. Repeating the same instructions again and again based on a condition. Based on a condition, you are repeating the same instruction set again and again. It is called repetition. Yes, is there any question? Yeah, you can check. Yes, you can check that way also. So you have asked questions. I am not, but that is basically what if you are checking all three together. So that can also be done. Like, yeah, you can check, but it's a bit confusing. That's why I didn't put all three. X, Y, Z. Actually, then in this situation, X should be greater than Y, and that should be Y should be greater than Z. So likewise, it's you can check like this, but this is a situation where so your condition is basically checking X greater than Y, and also Y should also be greater than Z. Right? That is the problem there. So that is a bit confusing. Right? You can say in this condition X is largest. Right? X is largest, but here to satisfy this condition, so actually X should be something like 65, Y should be something like 45, and Z should be something like 35. Actually, if you want to check, if you want to check the other way also, so you have to check O, where you can check then this one O, X is greater than, Z is greater than Y. The other way also. So then this is like full. Otherwise, the order should be like this, right? You can understand, I guess, because Y is here, Z is here. Then if you want to consider the order also, then YZ can be given this way, and also check in O, YZ can be given this way. But that is, I think, that is unnecessary, right? Unnecessary load. You can check like that, but that is unnecessary load. So let me show this. It's only one time I'm doing, just to show you this unnecessary load. I just want to show you. Okay, let's say X is 65, 45, 35. Yeah, you can see that detects. Then 65, 35, 45. That also detects. Then so this is you can see first and second are detecting. The third one is not detecting because I have not written the other things now. For X also you need to write this, and for Y also you need to write this. For Z also you need to write this. I think that is unnecessary load. But still it is valid statement. So in the MCQ questions, they can give answers like this and ask you whether this is correct. When they are testing the MCQ questions, they can give answers like this. Because multiple answers can be true. That can be tested in MCQ also. So that is also a valid statement. But only thing is like that is unnecessary load, but valid. Okay, repetition is repeat the same instruction set again and again. And what is done in the repetition here? Let me show something. Let's say you want to type, you want to input 10 numbers and get the total. Input 10 numbers, get the total of that. So let's write a code to that. First is basically you are starting. The second is you can set some constant value. The third thing is you are going to check that constant value for certain condition. The fourth thing is that you are going to do some task, or you're going to print this, or you're going to input the value. That is your input. With the input, I'm going to do something. With that input, I'm going to do something. And I'll come back and check whether the condition is still true. If not, I'll move and stop this. And one more thing I need to do, that is basically set in an increment or decrement, because this is to control the constant. It's not a constant, it's a variable, sorry. Start here. And let's say C, the variable is C, C equal 1. So what I'm going to check is C, whether it's less than or equal to 10, right? If so, I'm going to do that. If yes, I'm going to do that. What? If this is yes, I'll do that. So you have to convert this to a code now, right? Once I have written this in, once I create this flowchart, please convert this to working code. Because last day I just discussed about the, like what I just discussed about for and while loops. If you can remember, you can do this easily. Then here, what I'm going to do is I'm going to see in input and I couldn't this one thing, that is list total equals 0, 2 variables. Here I'm going to add to the totals equal total plus 1, so total plus the n. Then here I'm incrementing C equals C plus 1. C will be incremented by 1 by 1. So after incrementing the C, I'm rechecking whether this is still less than 10. If so, input the number, adding into the total, check increasing. So this will happen. 1, C is 1 initially. 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 equal to 10. Yes. Input 10, add in 1. Now it's 11. 11 is not less than or equal to 10. It will be stopped. From here, you need to write stop. So take a screenshot of this. What you need to do is please convert this to a code. Please convert this to a workable code, a working code. You can start now. Send me the answer in WhatsApp or in Zoom chat, whatever. Convert this to a workable code. With this, I think we have covered basically a long lesson. Basic control structures, sequence, selection, and repetition is a long lesson, like a 5-period lesson. We have just covered within 1 hour. So likewise, today I'm not going to discuss, hereafter I'm not going to discuss Python, because then this will be a kind of theory class. After that, we have discussed the question. Now we learn some amount of Python. Let's move to the next part. Okay, finish it very quickly. I'll give you 5 minutes. Okay, see here, I'm going to write the code again. So let's update the same one. Easy. You are taking this. You have to input n, right? So that is like there are some small mistakes in the code. Initially start with C equal 1 and the total equals 0. While you can say while C less than or equal to 10. What do you need here? Colon is must. Then what? You have to say n equal int input. This is what the machine is, right? I think those who have sent me the answer. So basically, missing thing is this. You have not taken the input. But the WhatsApp one is correct. INT input, then you have to enter the number. Or enter a number because you are going to do this 10 times now. Enter a number. Then the total equal total plus that number that you have entered, and then C equals C plus 1. And finally, after end of this, you can just print. So the total is, that is not mentioned there. Actually, but I'm just adding, right? Total is, that was not mentioned in the flowchart. Don't worry, that is not considered. Total is not, but you can just do something like this, will be more meaningful. Enter a number. Can we see this will be asked 10 times? The number will be asked 10 times, and so they will calculate the total at the end and print. That is what the code is. You can just copy this down. Okay, so now sequence, selection, repetition, everything done. There are different ways of showing that in loops. Let's go to the question paper quickly. So please write the answers for the question number. So now Python part is over 26, 27, 28, and 29, which we will discuss today. 26, 27, 28, and 29. Consider the following statement regarding the databases. So first statement. Candidate key is a column or a set of columns that uniquely identify a row in a table. Candidate key is a possible primary key. I think you can remember what primary key. Primary key is a minimal super key. What is a super key? Super key is any unique key which can be used to identify a row uniquely. Any key that can be any key or key combination which can be used to identify a row uniquely. Actually, from the super keys, we are selecting suitable super keys as candidate keys. So these candidate keys are these candidate keys are suitable to identify the row uniquely. But the thing is, we are not going to use all the candidate keys. We will select one candidate key from that. That is called the primary key. So primary key cannot be null, right? Can have null value? No, never. It cannot be null, right? Because the primary key is the unique identifier. If it is null, how can we identify? So it's a unique identifier, it's never be null. So that is C is wrong. Alternative key is any candidate key that has not been selected as primary key. That's true. Alternative key is any candidate key. So basically, there's a pool of candidate keys. It's like candidates, when for an interview, a set of applicants apply, those are candidates, selected candidates. So selected candidates are called for interview. Then from that candidates, one is selected, that selected one is called the primary key. The remaining guys are called alternative keys. Those are the alternatives people for that position. Alternative key, any candidate key that have not been selected as a primary key. So alternative key, let's A be true. So the answer number 3 is the answer. So according to your answers, yes, Situm, your answer is correct. Yes, your answer is also correct. Yes, who else sent the answers? Two. My God, so what about the others? Why you are not sending the answers? I hope you are in the class, right? Nicely. Varun, so you are not trying. What's wrong here? Okay, then what? Consider the following statement relevant to external entities of data flow diagram. External entities of data flow diagram. An external entity can be a person, system, organization that has predefined behavior. That is true. An external entity can be a source of input for a process and destination for output. Yes, it is also. External entities are always data stores. Is it? Will it need to be data stores? External entities are entities dealing with the system. Can be, it can take inputs from the system, can take output from the system. Right? That is the nature of external entity. But data stores are something else. Data stores are used to store data. Right? External entities are basically interacting with the system. Data stores are used to store data. Then what? So you can select answer number. Yes. Which is the answer number? Okay, Situm suggested answer number 3. Varun suggested answer number 3. Okay. Yeah, everybody selected answer number 3. That is what? A. B. A. External entity can be a person. Yes. Organization, system, anything. Yeah. External entity can be a source to the data, source for a data input, and so destination, yeah, that can be. Okay. Can consider say B only. Consider the following relational schema in a data. Relational schema is actually a logical representation. Logical representation of the table. Subject is the table, subject ID, term ID, subject description are the fields. Here, sorry, they're asking. Just give me a second. Okay, sorry. Here, the subject ID, term ID, and subject description are fields, right? Fields. Do you have that answer? Fields. No, then you can call attributes. If fields are not there, then attributes. Here, subject ID, term ID, these are called attributes. So, oh, it's number 1. Because, yes, and subject is the table or relation. Yeah, it's number 1. So very clear. Solid. No need to search, right? Here, this is like in the relational schema, we show the table and then the attribute or the field names. So what is the suitable primary key? Maybe we can select for subject. Subject ID can be taken as the primary key. Right? So, but they are not asking about that. Now, each of the following is most suitable to blanks. So these are the fields, basically attributes, and the subject is the table name. How simple that is, right? It's very easy one. 29. Consider the following task. Consider the following task. Identify the problem in existing system. Identify problem in existing system. Suggesting alternative solutions. Prioritizing of information system requirement. So, which of the above tasks are carried out during the preliminary investigation? Preliminary investigation is the basic. Basically, the system analysis. Before that, you do preliminary investigation of the system. So, problem is identified there. That is correct. Problem is identified there. So, that is correct. And not just that, alternative solutions and solution. That is feasibility study. Feasibility study means there are a lot of alternatives. Out of that, you select a certain specific one from the alternatives, like choosing the best feasibility. Economically, technically, environmentally, socially, legally, we consider the feasibility. Feasibility means the practicality of having that and select the best from the alternative. So suggesting alternatives are also coming under the preliminary investigation. Prioritizing the information system requirement, sure, yes, in the system requirement identification. Prioritizing functional and non-functional requirement identification. That is also basic. to be done at the preliminary investigation. So I can suggest all other correct answers. That is number 5, A, B, C. Tuple. Tuple is what? Tuple is a row record here. Within bracket they have given. Tuple is a row or record. The horizontal one, tuple is a row or record. That data is they have given is in the brackets. 30, 31, 32. Shall we find the answers quickly? 30, 31, 32. We can discuss. These questions are easy because theoretical. 30, 31, and 32. Question number 30. Which of the following feasibility types generally not carried out during the development of system? Development of system to be used only in-house. In-house means like within the plant, within the production plants, or not as a public. So then, which is not no need to be done because this is not public. We have to consider that factor here. Economical feasibility, yes, because that cost you, even though that is public or not, that will cost you. So economically, whether there is enough money or whether enough assets are there, you need to consider that. Market feasibility, you are not going to sell this outside, so it's not required. Operational feasibility, yes, you are going to operate this inside the organization, so need to be considered. These questions are easy, I guess, right? Okay, then organizational, yes, of course, because that is for the organization. Technical, yes, whether the available technology and what kind of technology are we going to use and whether this technology available, that need to be considered. Yes, that is true. So market feasibility is only one because we are not going to use that here in-house part. In-house means within the production plant, it's going to be used. So no need to consider about the market feasibility. 31. Consider following statements related to e-business. Brick and click is a business model which with a company integrates both offline and online presence of the business. It's brick and click. Brick and click companies, example, you can say Pizza Hut. You can order online, you can visit it too. Visiting means a brick company. If you can physically visit the place, it is a brick company. You can physically visit, buy, have, like dine in, all these are possible. That is brick. The click means you can order online. So it has online, offline presence. So that is brick and click. Yes. Pure brick companies, pure brick business is a model which company has only physical presence. Yes, that is true. That is brick companies, physically presence, not online. Pure click companies presence on the online environment. Yes, internet environments, only in the internet. Yes, pure click. So example, like now it's rare because like even the Facebook has physical presence, but their service is only delivered via internet, right? So you can consider that as a pure click company. A, B, C, all are true. So answer is number 5. Which chapter? The question number 30. Is it really required? So don't consider for the chapter. This is under system development. System development, maybe you can learn this in programming or in the systems chapter. That is coming under systems development. Right? Or information system development life cycle. Right? Under that it comes. Before coding, we need to learn about how to develop a system. In SDLC, software development life cycle, system development life cycles, integrate there. 32. Smart home application that automates the controlling, lighting, temperature, entertainment system, and appliances is example for smart home appliances. Automate controlling, lighting, temperature. This is IoT, right? Internet of Things. IoT system, because that is automated in the home environment. That is example for what? Evolutionary computing? No. Multi-agent systems are AI, artificial intelligence. No need to become AI to reply that. Multi-agent. Nature-inspired computing, no. Nature-inspired computing is where we look at the nature and then develop computers according to some natural phenomena. Example, ant colony algorithm. Ant colony algorithm is where the ants are forming colonies. So think that you put ants into a bucket and release suddenly. Then these ants are moving here and there. But after some time, you can see each ant follows the other ant. That will happen. So have you seen this? Colony, right? Basically, ant colony is where here you can see, first of all, you can see they are scattered here and there. But what will happen after some time? They will follow the same path. So it will create an algorithm, right? It will create an algorithm where you can see these ants are scattered, but later they will start following a similar path here. So that is used in for the robotics and automation. This is used because robots are moving here and there first, but after some time they will find the easiest path or the shortest path with the time. This is not just to find the shortest path, most convenient path. That is ant colony algorithm. That is nature-inspired computing. Another thing is swarm intelligent. Swarm intelligent. Swarm intelligence is where, here have you seen birds flying like this? Have you seen fishes, not just the birds, fish colonies? Not just the bird. You can see fish. So the small fish, they are attacking big fish like this, forming a colony. Likewise, it is possible to combine small AI agents, brains together, artificial AI, like this can be used for organizing drones in the sky. So master drone and slave drones, master drone and slave drones. So that is called swarm intelligent technology. So we use a master and we are going to use slaves to follow this master. So that is where the swarm intelligence comes. Especially this is applied for the robotics and drones. So they communicate within each other, and so that is a network group of brains. That is what the future intelligence is. Swarm intelligence here, network group of brains. Because they are not having a powerful brain, therefore they together take the decisions based on the facts. So those are nature-inspired computing, swarm intelligent, artificial intelligent, ant colonies. Software agents, that is also coming under artificial intelligence. Ubiquitous computing, sarvatrika pariganatha. That is the answer. Right? Ubiquitous computing means computers everywhere. That is IoT, IoET, Internet of Things, Internet of Everything. Everywhere the computers are used. So we call that ubiquitous computing. That is question number 32. The answer is number 5. Okay, the remaining questions let's discuss next week. Right? Then good night. See you all next week.